Okay, welcome back everyone. Today we are looking at using sprites in Pygame and looking at how to add sprites using object-oriented approach and managing collisions between those sprites in Pygame. Okay, so to start with, same as previously, I've given you some template code, very similar before, importing Pygames in random, some colors, we've got our screen, we've got our main loop down here, and I've filled it with white this time because we're not doing nighttime or snow. We're going to be doing some objects on the screen. So there's our template code. And the program you're going to be generating basically is going to be creating different objects, but this time we've got a player object that we can move, which is the red one here, and then we've got enemies, or if you want to call it objects, that we can collide with and have some interaction. In this case, we are removing them, almost like collecting them within the room, okay? And you can also see in the background our score is going up there as we are doing this. So this is what we are doing in Pygame today, looking at interaction with different objects using sprites. Okay, so one small difference I want to point out now. When we were creating the screen size today, before I just had the two properties for 640 by 480 within the size. These have now been separated out. So we've got a variable here for screen width, and we've got one for screen height, 480. And those have been plugged into the size little mini list here, okay? No difference apart from I've done this so that we can access the width and the height of the screen to use within the program today. Okay? Right, onto the main code. So we're going to start off today by actually doing some object-oriented program. Okay, so in this one we've looked at object-oriented program, we've looked at objects before. We're going to use classes and objects today to create our shapes and our objects within the game. Okay, so just under where it says add code here, so after we've made the screen, add code here, we're going to create our new class. We're going to create a class for a block class, if you want to call it, okay? And to do that, we do class, and I've called it block because it's going to be used to create blocks. Then in the brackets here, we've got pygame.sprite and sprite with a capital S. So what is this doing? Well, we've got our new class here, which we've called block, but inside here, when you put things inside here, it is inheritance. We are inheriting a package basically, okay? Pygame is the package because it's the Pygame package we've imported, but then I've gone .sprite and .sprite with a capital S. Now basically this is inheriting a parent class called Sprite that exists with Pygame, and it basically inherits everything we need to work with sprites today. Now if you want to know more about what you can do with sprites and all the different features, if you go to the Pygame website, you can see here all the different things that exist with the Pygame sprite object here, class, okay? We can do things like collisions, there are rendering, there's putting in groups and creating the sprites at the top, which is what we're going to start with doing today. So there are lots of things that we can do by having access to this. But for the moment, we're just inheriting it in here, okay? So inheriting the sprite class from Pygame. Okay, from there on, oops, lost it. The first thing you always have in a class is the constructor method. So just underneath here, constructor method. That's the first thing that happens in any class in Python. And we're going to go def underscore underscore, two underscores, remember, init for initiate underscore underscore. Make sure there are two underscores here. And then we're opening our brackets. This is where we pass in the values we need when we are going to instantiate or create our block. So we're going to do self, because it's referring to itself. We're going to have a color parameter. We're going to have a width, and we're going to have a height. So when we create an object, when we run the constructor method, or when we instantiate the object, we're going to pass in values for color, width, and height. And the self is because it's referring to itself. Okay. Now, next thing we're going to do inside our constructor class here, we are going to initialize the sprite class to use it. So pygame dot sprite with a capital S dot underscore underscore init underscore underscore self. So what that is going to run is basically that is going to call and initialize the constructor method of the sprite class that we've inherited here. So we've got our block class constructor, and now we're inheriting and running the sprite class constructor. Okay, so that's what we're doing so far. Okay, now we've actually got to do something with it. So next thing we're going to do is we're actually going to create a blank surface to draw in, ready for our sprite. So we're going to go self, because it's within this class, dot image equals pygame dot surface. So we're creating a blank surface, and we're going to use the width and the height that we've passed into this object to draw, width and height. And I've just realised those need square brackets because it's a little list there. Okay, so we've created pygame.surface capital S, and inside that we've got a square bracket, width and height. That is going to create a blank surface ready for us to draw on. Okay, now we're going to fill that surface. So we're going to fill that surface we just created with the colour that we're going to pass in up here. So we've got our width and our height being passed in, and now we've got a colour which we're going to fill it in with. So just down here, I'm going to go self.image.fill. So we're filling in the image we just created for the surface, and we're going to use the colour parameter that we've passed in here. Okay, and then finally, we're going to create a location on the screen with our variable to draw this onto. So basically what we're going to do is we're going to create a new rectangle and set it to the values of the self.image that we've made above. So self.rect, because we're going to do a rectangle, and we're going to go self.image.getRect. Okay, so that's going to create a new rectangle and set it into this object which we're creating above. Now, the location of this object by default is going to be set to 0, 0. Okay, by default, but we're going to move it later on once we've made the object. So at the moment we're just creating a blank rectangle in the screen on 0, 0, and then we will move it once we've made it. Okay, so we've now got our block class ready to use to create different rectangle shapes with different colours and different widths and heights and things. Okay, like last time, we're actually going to use a list to store the different shapes and objects that we are going to be making. So we're going to create a list for all the blocks that we're going to be making to collect or to collide with in the game. So we're going to call it block list, a list here, and we're going to go pygame.sprite.group. So basically we're using the sprite group option here to put all the different ones we're creating into a list, and it's going to help store them together. Okay, that's going to be all the blocks that we are going to be creating. However, we're also going to have another list. I'll explain why. Create list for all sprites. Okay, we're going to have another list down here, which I'm going to call all sprites list. Now, why do we need a second one for that? Pygame.sprite.group. Well, we want to separate out the objects that we're going to collect, the blocks that we're going to collect, or the enemies, if you want to call it. And we also need another one that has all the objects, including the player. So it's good to separate it out the different things. Maybe in your game you might have a list of all the coins you're going to collect, or bullets, for example. Okay, it's good to have a separate list for different objects and then a master list of all the sprites you're going to use, so you can call them and use them separately within the game, rather than having to mess around with one list with everything in. So now we've got our lists ready to use, we're going to do very similar to we did last time with the snow. We are now going to create a loop to create the blocks, the block objects in this case. Okay, so we're going to go for I in range, just like we did last time. And let's do 50 again, just because it's a nice round number. And I'm going to go block equals block capital B. I'm going to pass in the color. I'm going to pass in a width and the height. Well, what is that doing? This is going to create a variable here with an object from our block class that we created up here. Okay, so basically we're creating 50 objects, 50 block objects that are black, 20 width and 15 height. So these three parameters here are going to be passed up into our constructor, into our block class here, and creating them with the color, the width and the height using the constructor method here. So all we're doing is running the block class basically 50 times using the same values here. Okay? So that will create 50 objects. However, at the moment, remember, they're all going to be in the same place. They're going to all be in 0, 0. So once we've created them, we can then move them to a different random location. So block.rect.x, we're going to change the location of the block object we just created to a rand range, and we're going to use, rand range, apologies. We're going to use the screen width and the screen height variables that we've got here to change a location. I've just realized I made a mistake, sorry. We're going to use the screen width for the X, and then we need to do the same for the height. Block.rect.y equals random.rand range, and this one we're going to use the screen height. Now this is possible because at the top here, do you remember, we've separated out the screen width and the screen height. So instead of sorting 640 by 480, we've set it once, and now we can just use the variable. So later on we could just change the screen width and height and it would update the game. So it's a better way of doing it. So we're looping, we're creating 50 objects, 50 block objects of black for 20 and 15, and now we're randomly changing their X and Y positions. Finally, what we're going to do now is add them to our lists. We're going to do block list, which is the list we made, dot add, and we're adding our block because it's a block. And we're also going to add it to our all sprites list because it is also a sprite. Okay, so we've added it to just our block list, and we've also added it to the list of all the sprites, so we can manipulate all of them or just the blocks if we want to do something with that later on. If you do try and look through the code, just be careful because I have done one mistake there for I in range. Apologies. So just check your code, make sure you've got no syntax errors so far. Okay, so we've created our objects here, our block objects. We've randomized it, we've added them to our list and added them to all sprites list. However, if we run this at the moment, all I get is a blank white screen still. Okay, so even though we've made the objects, what we haven't actually done yet is draw those objects onto the screen. So to test to see if this works, if we go down now into our while loop and into the drawing section here, okay, before the pygame.display.flip, we're going to create our draw all the sprites basically we've made. So draw all sprites to screen. How do we do that? We're going to use our list, all sprites list dot draw, and the surface we want to draw to, which is screen. We've only got one surface at the moment, so it's called screen. And if we run that, we should have all of our block sprites being randomly shown on the screen now using the XY coordinates. Nothing else at the moment, but they're just being displayed to the screen from our list of objects that we've created. So it's working so far. Okay, so now we've drawn all our block objects, the enemies, so to speak. We're now going to add a player. So go back up to where we've created the objects for the blocks here, the bad guys if you want to call it. Just underneath, I'm going to create player sprite. Okay, and to do that, we're going to go, this time call it player instead of block. Player equals, We're still going to use the block class, and I'm going to pass in this time, instead of black, we're going to make the player red so he stands out. I can use the same size as well, like that. You can change the size, we can experiment with that in a minute. And then we're going to add the player to the all sprites list, because the player is a sprite, he's not a block, however. Okay, so we're adding him to the sprites list, which would then be created down below. And if you run it now, you'll see the player sprite up in the top left hand corner there, because it's defaulted to 0, 0. Okay, so we've got one red, one for the player, and then 50 block objects being created for all the other things to collect. Good. Okay, so now we've got a player object. Let's do something with him. Okay, we're going to go down to our main loop now. Okay, here, and we are going to get it so that our player can actually move. So inside our loop here, after we've drawn the player, we're going to go pos for position equals pygame.mouse.getPos. And basically all that's going to do is get the position, the XY position of the mouse, the user's mouse, and it's going to save it in this variable pos here. So whenever it moves, every time it goes from the loop, it's going to update with the new position of the player's or user's mouse. And then we are going to change XY position of player to their to the mouse. So we're going to go player, which is our object, .rect.x. So we're going to update the x position to position 0, which is the x position, because this here will return getPos will return a mini list of x and y, and we're going to use the 0, which is the x coordinate, and then we're going to go player.rect.y equals pos1, which would be the y coordinate. So we're using the pos, the xy, to update the position of the player. And if I run this, let's see what happens. I can now move my little player around the screen here, and it's following my mouse, where the other ones are staying still. However, at the moment, look, nothing happens when your player collides with the objects. Okay, so nothing happens. Let's change that. Let's make it more interesting, make it more useful. So what we're going to do is this. We're going to use a built-in method within the sprite class to detect collision. So we're going to go pygame.sprite.sprite_collide, okay, and we're going to say player, comma, block list, comma, true. What's this going to do? It's basically using the Pygame library and the sprite class, and it's using a method that's built in here to say if these two objects collide, it's going to do something. In this case, if the player collides with any of the objects in the block list, it's going to detect the collision, and true means to remove the thing that it's collided with. Okay, I could set that to false and it would detect the collision, but it wouldn't remove it. But true means remove it. Okay, so this is detect collision. Okay, let's run that to see what happens. Now, as our player object touches or collides with the other blocks, they start to disappear because it's removing them from the screen or from the object list. And gradually you'll see them disappear as I'm collecting or colliding with them. Okay, so that is a basis of collision. Now there are different types of collision you can use. This detects the collision and removes it, but there are other built-in methods you can use. But for the moment, let's have a go at this one. Okay, now that's good, but it'd be also good if we could do something else that happens when you collide. Okay, so instead of just using this method, we can actually do it in a selection. So I can take that line and I'm just going to go if the player collides with the block object, colon at the end to finish it off, we are going to use score. we're going to add some score. So basically say when you collide with a block object, we're going to add to a score. Okay, so to do that, we're going to go score plus equals 1. And then I'm going to print the score out onto the screen. Okay, so if the player collides with any of the objects in the block list, remove them, add 1 to the score, and then print the score onto the IDLE in the background, into the working shell. Only other thing, before you can use score, you have to initialize it. So just before the loop up here, I'm just going to add score equals 0. Okay, so set it off. So before the loop, score equals 0. Then in the loop, if you collide with a block object, add 1 to the score and print the score on the screen. And if you go ahead and run this, what you should have is something like this. My sprite objects, as I collect them, in the background there, you can see the numbers going up in the shell as it's adding to my score variable and doing that. Okay, and then collect them all like that nicely. Okay, this has been quite a long video. Final challenge then. If you've managed to get this working so far, which I hope you have, let's have a go at your challenge. So your challenge is this. I want you to see if you can extend this program to add text to it. So instead of showing it in the shell, we've got a text label that updates with the score. Remember, we've got a score variable, so you just need to change the text that's been generated on the screen to include that label. And also, final thing, when you've collected all the objects, it pops up with a message saying game over or level complete or something like that. To do that, you'll have to look at the block list and see if it is empty. If block list equals 0, if the length of the block list equals 0, and that will tell you if all the objects have been collected or not. And then a message popping up on the screen saying game over. There's your challenge. Good luck. See you in class.